Check, 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 check. Check. Online students, can you hear me clearly? Online students, can you hear me clearly? Please confirm with a message. Zoom students and the students in the YouTube live chat. Okay, so let's start the session. Uh, let's start the session. So today's main target is, yes, I know that 3 hours is too much, but the plan is check, check. Okay, so target is to do a bunch of questions. So I know 3 hours will be too much. So the target was just to assign 3 hours, but we are not going to continue for 3 hours. So don't worry about that. If you are able to finish the required set of questions, I'll finish it in that time. Okay. If you are able to finish the required number of questions, maybe like if the required set of questions are finish after 2 hours, then let's stop the session at 2 hours. If it goes for 3 hours, let's see what to do. If it is too much or if you feel like it's too much work, just let me in the Zoom chat. Okay? If you feel like it's too much work and a lot of trouble, just let me in the Zoom chat. Then I'll arrange another session to do the remaining part. Okay? Then I'll arrange another session to do the remaining part. Let's do it that way. Okay. So students, first of all, let me know, can you hear me clearly? Can you hear me clearly? Let me know, can you hear me clearly? Okay, so then let's start. Okay, so go to the tute. Okay, go to the tute. That's the usual tute that we use for all the sessions. Okay, so to explain things a bit, අද කරන්නේ English medium session එකක්. අපි සිංහල medium session උත් කරගෙන ගියා. එතකොට සිංහල medium ළමයින්ට අපේ channel එකේ තියෙනවා සිංහල medium sessions ටික. So today we are mainly focusing on English medium again, and we did a bunch of English medium sessions before, okay? We did a bunch of English medium sessions before. And all the recordings will be provided in the group, and they are anyways available in the channel, okay? They are anyways available in the channel. There's a WhatsApp channel that you can get all the resources. So that WhatsApp channel link will be provided in the group again, okay? That's what that WhatsApp channel link will be provided in the group again. You can join that WhatsApp channel and get the recordings of all the previous stuff. All the previous stuff means we did waves and optics, we did mechanics, we did electromagnetism, we did electronics, uh, we did work power energy equilibrium and work power energy equilibrium and hydrostatics. We did a series of sessions for English medium students, and today we are going to discuss questions from a lot of areas, okay? So that is the target. So go to the tute, everyone. Go to the tute. Tute in the sense the usual tute that we use for everything, okay? Tute means the usual tute that we use for everything, okay? So go to the tute. Hope you can find the tute. Provide the tutes again in the Zoom chat. So tutes will be again available in the Zoom chat, okay? And in the YouTube live chat. Provide tutes in the Zoom chat and the YouTube live chat. Well, okay. So let's start with the questions. Okay. Let's start with the questions. Let's start from mechanics. Okay. Let's start from mechanics questions and whole answer script. Okay. Whole answer script of this tute will also be provided. Okay. The whole answer script of this tute will also be provided. And if you don't receive something like that, if you need any other assistance or if you need any other support, contact our hotline number 070-154-6 825 6825 not 70-154-6825. Okay, so let's start. Okay, so let's start from page 5. Let's start from page 5. Let's start from page 5. Go to page 5. Sorry, let's start from page 4. Go to page 4. Motion questions. Motion questions. Go to page 4. Before moving to that, I'll like revise you the rough theorems that we know. Okay, I'll revise you the rough stuff we know. We discuss about displacement time graphs. In this lesson, we discuss about displacement time graphs, velocity time graphs, and acceleration time graphs. Okay, we discuss about displacement time graphs, velocity time graphs, and acceleration time graphs. So what is the relationship between them? What is the relationship between them? So mainly displacement is basically the gap between 2 points. Displacement means basically the gap between 2 points. And velocity means how fast do you spend this displacement. That means displacement over time. Velocity means displacement over time. Then what is acceleration? What is acceleration? Acceleration is how fast does this velocity change. Acceleration is how fast does this velocity change. And again, talking about the units, this is measured in meters. This is measured in meters per second. This is measured in meters per second squared. Okay. Then talking about the graphs, if you have a displacement time graph, the gradient of the displacement time graph, will provide you the velocity, and the gradient of the velocity time graph will provide you the acceleration. And by taking the area under the curve of an acceleration time graph, you get velocity, and by getting the area under the curve of a velocity time graph, you get the displacement. Clear? You get the displacement. Okay. So that is the basic idea. Okay. That is the basic idea. Let's go to questions. Go to page 4. Go to page 4. Question number 1. Go to page 4. Question number 1. An object starting from rest moves with an acceleration of 1 meters per second squared for 10 seconds. Relevant graph for its motion. An object starting from rest moves with an acceleration of 1 meters per second squared for 10 seconds. Relevant graph for its motion. So they are talking about a acceleration. They are talking about an acceleration of 1. They are talking about an acceleration of 1. An acceleration of 1. So who can show an acceleration? A velocity time graph. A velocity time graph can show the acceleration. So this should be a velocity time graph. How does the velocity time graph show an acceleration? The gradient of the velocity time graph is the acceleration, right? The gradient of the velocity time graph is the acceleration. That means I should draw a velocity time graph with a gradient of 1. So according to these answers, in 10 seconds, if the velocity reached to 10, in 10 seconds, if the velocity reached to 10, then the acceleration is 1. Why? Acceleration means change in velocity over change in time. So here change in velocity is 10, and here the change in time is 10. So velocity changes by 10 within 10 seconds, which provides us 1 meters per second squared. This provides us 1 meters per second squared. So we have this answer at the second one, right? Second one is the answer. Clear? Second one is the answer. Let's go to the second question. Let's go to the second question of page number 4. Second question of page number 4. The velocity time graph that correctly represents the motion of a stone which is thrown upward on 100-meter tower returns back to the ground. So what is the question that matches with this? What is the answer that matches with this? Page 4, question number 2. Page 4, question number 2. Online students, if you can't find any tutor or have any other issue, let me know, okay? So, there's a tower like this. There's a tower like this. We throw something like this, it goes up, 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 stops, then falls down, 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 and reach to the bottom, and reach to the bottom. What is the velocity time graph of this guy? එයාගේ ප්‍රවේග කාල ප්‍රස්ථාරය මොකක්ද? What is the velocity time graph of this guy? I'm not going to do all the questions. I'm going to do the important questions and somewhat difficult questions, because all your life, your level teachers may have explained you the easy questions. So let's do some few challenging questions, few questions that you may find difficult. Let's do few like challenging questions like that, so that it would help you, support you in all levels properly. So here, now in any velocity time graph, we should choose what is a positive direction. That means if something moves in this direction, if it is considered as positive, when it moves down, it should be considered as negative. So what happens with the velocity is, it starts with a positive velocity. Why? It goes up. But this velocity reached to zero, right? At the highest point, this velocity reached to zero. At the highest point, this velocity reached to zero. So we start from a certain velocity, then we reach to zero. Clear? We start from a certain velocity, then we reach to zero. Then we start falling back. Then we start falling back. That means velocity starts becoming negative. Velocity starts becoming negative. Here, velocity starts becoming negative, and it goes in the opposite direction. Clear? And it goes in the opposite direction, and it reach here, and it move further down. It move further down. So this should go further down like this. First one should be the answer here, right? First one should be the answer. Clear? Starting from a positive velocity, go to zero, go in opposite direction, and go a huge direction in opposite direction until the bottom of the tower. Until the bottom of the tower. Clear? And if you can't figure out any question, let me know, okay? If there's a question that you can't understand, let me know, okay? Okay. Okay. Page number 5. Page number 5. Question 3. Number 3. That means the first question of page number 5. The highest question. The first question of page number 5. Question 3. A ball is projected upward with a velocity 40. The distance traveled by the ball when it reaches half of its maximum height is. When it reaches half of its maximum height is. So it's like this. If I throw something up, it will go up, 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 and at the highest point it will stop. It will go up, and at the highest point it will stop. That means at the highest point velocity will be zero. Okay? At the highest point the velocity will be zero. Okay? Then if I draw the velocity time graph for this one, okay? If I draw a velocity time graph for this one, I start with a positive velocity. I start with a positive velocity. Here, I start with a positive velocity. What is the value? Starting velocity is 40. Starting velocity is 40. I start with a positive velocity of 40. Then I go to the highest part, reach up, 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 and stop. That means at the highest point, velocity goes to zero. That means velocity goes from 40. Velocity goes from 40 to zero. Clear? In this case, velocity goes from 40 to 0. Here, velocity goes from 40 to 0. And this is the velocity time graph. Area of this graph will provide me the maximum height it reach, right? Area of this graph will provide me the maximum height it reach. Here. Then when I get the maximum height, okay, first of all, I have to find this area to find this height. So I'll mark this time as t. Now tell me, what is the gradient? Tell me, what is the gradient of a velocity time graph? Gradient of a velocity time graph is acceleration. Okay. Gradient of a velocity time graph is acceleration. Then acceleration is change in velocity over change in time. And in this case, change in velocity is 40. Change in time is t. So change in velocity is 40. Change in time is t. And what is the acceleration? Can you tell me what is the acceleration of anything that moves under gravity? What is the acceleration of anything that moves under gravity? Acceleration of anything that moves under gravity is 10, right? It's gravitational acceleration. Acceleration of anything that moves under gravity is 10. It's gravitational acceleration. So when I solve this, I get t equals 40 over 10. T equals 40 over 10, which means 4 seconds. So the time here is 4 seconds. Now, what is the area? Area of the curve is the height it travels, right? Why? Area of a velocity time graph is the displacement, right? Area of a velocity time graph is the displacement. So what is the area of this graph? It is a triangle, right? It is a triangle. So what is the area of this graph? 40 height into 4, 40 into 4 over 2, right? Area of the graph is height 40. This is 4 over 2, which gives me 80 meters. Area of a triangle 40, 4 divided by 2, which gives me 80 meters. But what they ask is not the maximum height, half of its maximum height. They're asking half of its maximum height, which means h over 2. They're asking h over 2, half of its maximum height. That means 80 over 2, which gives me 40 meters, okay? It gives me 40 meters, okay? Okay, okay. Let's move forward. Move to the next question. You can see, but I'll let you know a question number. Okay, let's go to question 6 of page number 5. Question 6 of page number 5. Let's go to question 6 of page number 5. Question number 6. A fruit in a tree that detaches from the torque takes 2 seconds to fall to the ground. What is the velocity when it reaches the ground? Again, I usually prefer graphs almost. Yes, you can use x equals 5t squared. I think some of the O-level teachers may have explained you this. S equals 5t squared. If you like, you can use that too. This kind of stuff. But I mean, graph is the most fundamental thing. So there's nothing to go wrong in a graph, okay? Yes, you can use s equals 5t squared. That means the idea is there's a formula like that. Question 6. For anything that starts from zero velocity and drops under gravity, drops under gravity, I mean, this is not related to question 6. Actually, this is related to the previous question. The distance it travels, you can get using s equals 5t squared. That is the distance it travels in time t. Okay. So for anything that falls under gravity, the distance it travels in time t, you can get using 5t squared. Yes, this is a possibility, but I always prefer going for graphs because there's nothing to go wrong in a graph. Okay, that's what you know. There may be a starting velocity, there may be a negative velocity starting. Whatever happens, right? Whatever happens, you can still, okay? Whatever happens, you can still use motion under graphs, right? So I usually recommend graphs a lot. So going to question 6, okay? Moving to question 6. There's a fruit starting from zero velocity. It takes 2 seconds to fall. It takes 2 seconds to fall. What is the velocity when it reaches the ground? What is the velocity when it reaches the ground? So again, let's consider this as the direction and draw a velocity time graph. How? What is the starting velocity? 0. Starting velocity is 0. Then velocity keeps increasing. When it falls down, velocity keeps increasing. It keeps increasing for 2 seconds. It keeps increasing for 2 seconds. The question is, what is the velocity after 2 seconds? What is V1? So again, gradient of a velocity time graph is acceleration. Gradient of a velocity time graph is acceleration, or the slope. Slope of a velocity time graph is acceleration. Here. Then what is the velocity difference here? It's V1. Velocity difference here is V1. What is the time here? 2. So it's V1 over 2. It's V1 over 2. What is the acceleration here? It's falling under gravity. It's falling under gravity. So I'll take gravitational acceleration as 10. Sometimes you have to take it as 10, sometimes as 9.8 should be given. So here acceleration is 10. Acceleration is 10. Then what do we get? 10 equals V1 over 2. So V1 equals 10 into 2, which gives us 20 meters per second. 20 meters per second. Here, that's how we get the answer. Okay. Now, just let me know, is it clear up to this point? Mention in the chat. Mention in the chat. Is it clear up to this point? Good message. Nice. Nice. So let's move forward. Let's move forward. I'm just choosing the proper question numbers, but don't worry. For all other questions, there's an answer script, okay? You can check your answers with that answer script, okay? I'm doing both teaching and explaining the concepts here, so I can't go through all the questions, but to confirm your theory, you can try other questions too. Those answers will be provided as a nice typed answer script, okay? Let's go to question 7. Let's go to page 7. Wait a bit. Let's like go through the theorems a bit. Theorems in Newton's laws. Okay. So that book you're referring now, it's a nice short note about everything. Okay. It's a nice short note about everything. And contact this number. Okay. Contact this number for anything. Okay. Note 70-154-6825. Okay. And I forgot to start the session by telling who I am. I'm actually I'm Chani Dulilanand. I'm an engineer from University of Moratuwa and currently working as an engineer and a advanced level physics tutor. Advanced level physics tutor. Okay. So if you are doing science for A level, science in the sense maths or bio, if you are doing maths or bio for A levels, we'll meet again. So moving forward, about Newton's laws of motion, there are 3 laws. What are the Newton's laws of motion? What is the first one? First one, if there is no external unbalanced force, system remains stationary or it continues with a uniform velocity. That means if there is no external unbalanced force on the system, if no one's applying an external unbalanced force on the system stays stationary. Okay. System stays stationary or it will move in a constant velocity. Newton's second law, how this motion changes. If the mass of the object is m, if we apply a force of F on the object, we can apply F equals ma and get the acceleration F over m. Then the third law, every action has a reaction equal in direction, equal in magnitude, opposite in direction. That means if this object creates a force on this object F, the reaction will be on this object in the opposite direction. Clear? If this object creates a force on this object, if the force is F, the reaction is on the other object and it is in the opposite direction. Clear? Okay, this is the action-reaction pair. These two forces are equal in magnitude and opposite in direction. And this force we measure using Newtons. Okay. Okay. So let's go to page number 7. Let's go to page number 7. Question number 2. Page number 7, question number 2. Let's go to page number 7, question number 2. Okay. Page number 7, question number 2. A box of mass m is pushed, causing it to accelerate a. If the same force F is applied to a box of mass 2m, how will its acceleration change based on the relationship A is inversely proportional to m? Convenient question. How? Page number 7, question number 2. If we apply a force of F to a mass m, it gains an acceleration of a. So F equals ma. F equals ma. Now if the mass becomes 2m, with the same force, what is the acceleration? So again we can write F equals ma. Now the force is still F, but the mass is 2m, then into a. So it's the same force, but the acceleration is changing here. So since these two sides are equal, this ma is equal to this 2ma1. M and m cancels out. A1 equals a over 2. A1 here equals a over 2. Okay. When the mass is 2m, acceleration becomes half. Acceleration becomes half. Okay. Next. Let's go to question 5 of page number 7. What is question 5 of page number 7? Calculate the acceleration of an object of mass 5 kilograms when an unbalanced force F of 10 Newton is applied to it. Okay. So question 5 of page number 7, F equals ma. So what is the force? It is 10 newtons. Force is 10 newtons. Mass 5 kilograms. Acceleration a. They need us to find the acceleration. So acceleration becomes 10 over 5, which means 2 meters per second squared. 2 meters per second squared. Okay. Then there's another concept that we have to learn, that is momentum. Momentum is the multiplication between mass and volume, mass and velocity. Momentum is the multiplication between mass and velocity. Mass is measured in kilograms, velocity is measured in meters per second, okay? Mass is measured in kilograms, velocity is measured in meters per second. So it is kilogram meters per second. Okay. Okay, let's go to question 2 of page number 8. Let's go to question 2 of page number 8. Question 2 of page number 8. An object of mass 5 kilogram moving at a velocity 4 collides and joins with a stationary object of mass 3 kilograms. What is the total momentum of the system before the collision? They are asking for the total momentum of the system. Okay. They need us to find the total momentum of the system. Total momentum of the system. So in that case, there's an object, question 2, page 8, a mass 5 kilogram moving at a velocity 4. It collides and joins with a stationary object. 3 kilogram, but it is stationary. Velocity is 0. What is the total momentum of the system before the collision? What is the total momentum? Mulu gammetave. The total momentum T is momentum of this guy plus momentum of this guy. So here it is 5 into 4. Mass into velocity. 5 into 4. Here it is 3 into 0. Here it is 3 into 0. 5 into 4 plus 3 into 0, which gives us 20. This is 0 kilogram meters per second. So there was another question about theory sessions. Yes. We may be doing more theory sessions, okay? There are plans to do more theory sessions too. But until now, we have done theory sessions for electronics, electromagnetism, work power energy, equilibrium, optics, geometric optics, hydrostatics. Like that, we have done a series of current electricity we did, series of sessions, and current electricity optics sessions we did with demonstrations, okay? Current electricity and optics sessions we did with demonstrations, with proper demonstrations, so that like you can see what is actually happening, proper physical demonstrations, okay? So go through those content, okay? You will find that useful, okay? Okay, then what is friction? What is friction? If there's a object and if it tries to move relative to the flow, okay? If there's an object, if it tries to move relative to the flow, there will be a possibility of relative motion between them, okay? Then there will be a possibility of relative motion between them. If there's a possibility of relative motion between them, friction always try to stop that. So the friction will act in opposite direction, okay? Friction will act in opposite direction. And what factors decide the value of the friction? It is the nature of the surface. It's the nature of the surface. That is one factor. Nature of the surface. And what are the other factors? Definitely the weight. Definitely the weight of the object. Definitely the weight of the object. Okay. Why? It decides the reaction here. It decides the reaction here. Okay. We call that the normal reaction R. Normal reaction R. So what are the factors? What are the factors? It's the nature of the surfaces. If it is very rough like this, or if it is very smooth like this, and the normal reaction, that means the reaction force acting between them. What does not affect that? What does not affect that? Definitely the surface area in contact. Okay. The surface area in contact have nothing to do here. Okay. Surface area in contact have nothing to do here. How can you increase the friction? Make it rough, make surfaces rough. How can you decrease the friction? Make surfaces smooth by polishing them. Okay. Make surfaces smooth by polishing them. Okay. So there are few methods like that. Okay. So moving forward with questions, let's go to page 11. Page 11, question number 2. Let's go to page 11, question number 2. Page 11, question number 2. So in the figure, a force of 3 Newton is applied to a wooden block placed on a rough table. What is the static friction that would be generated if the block of wooden block did not move? Okay. Then there's another term. There's another term called static friction. I'll explain that part too. Okay. Like when you apply a force, sometimes object will not move. You apply the force, but the object is not moving. Clear? You apply the force, but the object is not moving. Okay. So sometimes things like that happens. That means object is not moving. That means friction is holding. Friction is holding the object. It doesn't let the object move. The friction we have in that situation, we call that the static friction. Okay. We call that the static friction. Then there's a maximum value this static friction can get. There's a maximum value this static friction can get. We call it the dynamic friction. We call it the limiting friction. We call it the limiting friction. The maximum value that static friction can get, we call it the limiting friction. And if we pass this limiting friction, the object will start moving. Then the object will start moving. Then the friction here, we call it the dynamic friction. We call it the dynamic friction. So in question 2 of page 11, there's an object like this, a balance like this, a balance like this. Now, this is under static conditions. That means the object is not moving. And the Newton balance shows 3 newtons of force. Newton balance shows a 3 newton of force. What is the meaning of that? That means there's a force of 3 newtons in this direction. Then if the object is not moving, definitely there should be 3 newton in opposite direction, right? If the object is not moving, definitely there should be 3 newton in opposite direction. Clear? It's 3 newton in this direction and 3 newton in opposite direction. Clear? So in this case, friction, static frictions should be 3 newtons. That's why the object is not moving. Clear? Object is not moving because the static friction is 3 newtons. Clear? Static friction is 3 newtons. Okay. Yes. If this is 3 newtons, this should be 3 newtons so that the object does not move, right? If there is a resultant force, the object will be moving. Clear? If there is a resultant force, object will move. In this case, it is not moving because it is 3 newtons in this direction and 3 newtons in opposite direction. Let's go to question 3, page number 11. Page number 11, question 3. Question 3, page number 11. Several strategies used to increase friction are given below. Making grooves at the sole of the shoes. Grooves are etched on the surface of the tires, making the rubber brake pads rough. What are out of these strategies? The strategies used to make the motion easy are. I mean, yes, we can call all are correct in a way. Like we can call all are correct. It's based on how we interpret. But the idea is when you make grooves on the surface of your shoe, when you make grooves on the surface of your shoe, it'll bind with the earth properly. It'll bind with the earth properly. Yeah? It makes your walking easy, right? It makes your walking easy. And the same story with the tires. Okay? The more grooves you have on the tires, more binding between the earth and the tires. More binding between the earth and the tires, which make it easy to roll. Making the rubber brake pads rough, definitely. Whenever you need to stop a motion, you use brake pads. And when they are rough, I mean, how brake pads work is when the tire moves like this, brake pad come and press against that and create a friction. Okay, It just comes and rests again the wheel and creates a friction such that the wheel can't rotate. So making that brake pad rough will create a proper binding between the tire and the brake pad. So in a way, it makes our motion easy by letting us stop the vehicle whenever we need to stop that, okay? It helps our motion by letting us stop the vehicle properly whenever we need to stop it. Yeah, whenever we need to stop it. That's the idea. Okay. There's a bit hard question. Some students find this question hard. So I'll do this one, okay? Some students find this question hard, so I'll do this. Page 13, question number 4. Go to page 13, question number 4. Two persons apply two forces on a Newton spring balance as shown in the diagram. What is the reading of the Newton's spring balance? What is the reading of this spring balance? Okay. So this is the idea. This is the idea. There's a spring balance like this. There's a spring balance like this. So the story is one person applying 100 newtons in this direction, okay? Then another person applies 100 newtons in this direction. Some people think the total answer would be 200 newtons. That is not correct, okay? Some people think that the total answer would be 200 newtons. That is not correct. It's still 100 newtons. Why? Why? I mean, the reading of the spring balance is actually the force applied on the spring. So, this 100 Newton is only applying a force on the frame of the spring balance. It's not on the spring. It's not on the spring. It's applying a force only on the frame of the spring balance. Only on the frame. Okay. It's applying a force only on the frame of the spring balance. Clear? Only on the frame of the spring balance. Clear? That force is on the frame, not actually on the spring. So only force actually acts on the spring is this 100 newtons. What this guy does is it only stops it from moving. Okay, it just stops it from moving. Otherwise, if this person is not holding, when you apply 100 newtons, the spring will not stretch. The spring balance will go. Okay, the spring balance will go. Spring balance the correct one, okay. Spring balance will just go. So this person just hold in the spring balance without letting it go. It does not affect the spring. Okay. It does not affect the spring. So the reading is 100 newtons. Let me know. Is it understandable up to this point, everyone? Okay, next topic. Next topic, moment. Moment of forces. Moment of forces. So what is the moment of force? What is the moment of force? Moment of force is the rotational impact on something. It's the rotational impact of something. If you have an object like this, if you apply a force like this, see, it will rotate here. If you have an object like this, if you apply a force like this, see, it will rotate. So the value of this moment of force depends on the force and the distance. That means if this is an object, if it is rotating around this point, if you apply a force here, and if the distance, if the perpendicular distance to that is x, the moment of this force would be fx. Sometimes the moment is created by a couple of forces. Okay, that means what is a couple of forces? Couple of forces is two equal forces acting in opposite direction. A couple of forces is two opposite forces, see, like this, two opposite forces acting on the same object. In a scenario like this, the moment created by this couple of forces is magnitude of one force and the distance between them. Okay, in a scenario like this, the moment moment created by this couple of forces is for magnitude of one force into the distance between them. Okay, so let's go to page 17. Let's go to page 17. Question number 6. Page 17, question number 6. Let's go to page 17, question number 6. A uniform beam AB of 1 meter in length is kept in equilibrium by suspending it from the point P as shown in the diagram. Find the weight of the beam. They are asking us to find the weight of the beam. Tell me in the chat, where do you find the weight of a uniform beam? Where do you find the weight of a uniform beam? Where can you find the weight of a uniform beam? Tell me in the chat. Where can you find the weight of a uniform beam? Mention in the chat. No one? No one? No. If something is uniform, their weight acts at the center. Their weight acts at the exact center. If something is very uniform, we mark their weight at the exact center. Here, if something is very uniform, we mark their weight at the exact center. Okay. So in this case, in this question, question 6. This AB is very uniform and its length is 1 meter. 1 meter means 100 centimeters, right? 1 meter means 100 centimeters. Then their weight acts exactly at the middle. Their weight acts exactly at the middle. And it is balanced. Around a point like this. The distance to this weight is 50. Distance to this weight is 50 and this distance is 30. This distance is 30. This is 30. And we have applied 20 newtons here. Now, it is balanced around this point, right? It is balanced around this point. If something is balanced around a certain point, that means it is not rotating around that point. That means there is no moment around that point. So in this case, if I consider this point, there's the weight acting like this. Weight acting like this at a distance of what? If this is 50, if this is 30, the remaining part is 20, right? If this is 50 and this is 30, the remaining part is 20. So this distance is 20. This distance is 20. So this creates a moment in this direction. This creates a moment in this direction around this point, and the value is W into 20. W into 20. Okay. Moment is weight, the force into distance. And this 20 Newton creates a moment in opposite direction. You can find these 20 Newtons acting here. And the distance from here to this 20 Newtons is this 30 centimeters. Is 30 centimeters. So there is an opposite moment created by that 20 Newtons, which is 20 into 30. Which is 20 into 30. And these two moments should be equal. Here, these two moments should be equal. W into 20 equals 20 into 30. Clear? W into 20 equals 20 into 30. Why? It is balanced because there is no moment. The moment in this direction is balanced by the moment in this direction. When they are equal, it stays calm. Clear? When they are equal, it stays stationary. So using this, I can find the weight W. W equals 20 into 30 over 20. We get 20 and 20 cancel out. We get 30 newtons. So the weight of the object is 30 newtons. Here, weight of the object is 30 newtons. Okay. And all other questions are almost similar to this scenario. Okay. All other questions are similar to this scenario. Okay. But let me know if there's a question. I can't guarantee all, because when I ask this, all the students mention all the questions, then we can't keep up with the plan. But just mention the question numbers around that you need us to explain. If there's a lot of students who require the same question, I'll do that. Okay. Let's do it that way. And why is it 50? Why is it 50? That is the meaning of uniform. Okay. That is the meaning of uniform. Okay. That is the meaning of uniform. And yes, mention the areas you need me to focus a lot. Okay, because I just started to do things from beginning, but there may be areas that you find very difficult. Okay. So just let them in the Zoom chat. Okay. Mention them in the Zoom chat so I can focus on them. Okay. I can focus on them. That is the plan. Okay. So just let me know in the Zoom chat. Okay. So the whole meaning of uniform means it's mass is equally distributed, its weight is equally distributed, so that the total weight acts at the exact center of the object. That is the meaning of uniform. Meaning of uniform means whole weight is distributed uniformly, and it is so that it acts at the middle. So total length is 100 centimeters. So at 50 centimeter you can find the weight, and the object is balanced around this point. Why? This W creates a moment in this direction, and this 20 newtons creates a moment in this direction. When they are balanced, it stays like that. This is what happens in a normal balance actually. You see in the market. You see in the market what happens. What happens in a balance you see in the market. You put some weight here, then it go unbalanced. Then you put some more weight here, then it gets balanced. Why? The moment in this direction, that means F1, X1 in this direction gets equal to the moment in the other direction. That means F2, X2, F2, X2, F1, X1 becomes equal to F2, X2. Clear? That is the idea. Clear? Clear, people? So the same scenario here. Same scenario. Now is it clear? The students who asked the question, is it clear? Question, do we have to convert centimeters into meters? Ideally, yes. Ideally, yes, but I didn't do that. Why? I didn't do that because I write both sides in centimeters. See, I write both sides in centimeters, 20 centimeters, 30 centimeters. So when I write centimeters in both sides, they anyways cancel out, right? So whatever the conversion I have to do here and here both, so they will anyways cancel out. So in that case, I don't have to do the conversion. Okay, that is the idea. That's why I didn't do the conversion. Okay. So then equilibrium. Okay. Then equilibrium concepts we have already discussed. Okay. Equilibrium concepts we have already discussed. The moment is not over. I'll do a few more questions from moment 2. Okay. But I just need some more ideas from equilibrium to explain things better. Like under equilibrium of forces, can you remember? We discussed equilibrium of two forces. We discussed equilibrium of two forces. For the equilibrium of two forces, they should be equal and opposite and in the same line of action. For the equilibrium of three forces, sum of two forces, F1 plus F2 should be equal to the third force. Sum of two forces should be equal to the third force. And for the equilibrium under three forces that are not parallel, they should meet at the same point, and the resultant of two forces should be balanced by the third force. Clear? Resultant of two forces should be balanced by the third force. Clear? So that is the idea. That is the idea. Okay. So this is equilibrium. We did a separate session for equilibrium. Okay. We did a separate session for equilibrium. Okay. So Okay, so moving forward. Okay, moving forward, go to page, go to page 19, go to page 19, go to page 19. Question number 1. Question number 1, page 19. Question number 1, page 19. The diagram shows balancing a fish on a blade of a knife. The factor that is affected to balance the fish on either side of the balance point is equal weights, equal length, equal moment, equal mass. Now tell me the answer. Tell me the answer. Page 19, question number 1. Tell me the answer. It's a nice question. Question number 1, page 19. Just put the answer until I erase the board. What is the answer? Oh, I'm receiving all the answers. 1, 2, 3, equal moments, equal weights. I'm receiving all the answers. See, that means you find that hard, right? If the question is easy, all the students should give the same answer. Okay? The question is easy, all the students should give the same answer. That's not the case here. So the answer is it's equal moments, okay? It's equal moments. Why? Because what actually happens is the fish is balanced on a point like this. Fish is balanced around a point like this. Okay. Fish is balanced around a point like this. So what actually happens is there's a moment from this side. It tries to rotate in this side. And there's a moment in this side. It tries to turn in this side. If these two factors are equal, then only it stays stationary. I mean, how can you analyze this? Just think, if it is not equal, what happens? If it is not balanced, it just rotates, right? If it not balanced, it just rotates. So who creates rotation? Moment. So it's what is balanced here is moments. That's why if it is not balanced, it rotates. Okay. Things tend to rotate when the moments are not balanced. Okay. So what is equal here? It's the moments of the two objects. Okay. It's the moments of the two objects. So talking about hydrostatics, okay. Talking about hydrostatics, I'm gonna go through more questions, okay. Don't worry. Like, I think can't rush a lot. So if a lot of questions get remained, if you feel like you need more sessions, I'll anyways do more sessions. Okay, let's do it that way. Okay, we'll see. Okay. So hydrostatics, I'm not gonna do again because we did a whole session about that. You can watch that recording. But the rough idea is in hydrostatics, at a level of H, the pressure is H rho G. At a level of H, pressure is H rho G, and this pressure is equal in all the direction, and it does not depend on the shape of the column. It doesn't depend on the shape of the water column. It only depends on the height of the water column. Okay. It only depends on the height of the water column. Okay. So things like that we learned. Okay, we did a separate session for hydrostatics. You can watch that recording from our like just join our group. Okay, join our group, and the WhatsApp channel. All the resources are available there. Okay, you can find all the resources there. So now moving forward. Okay, moving forward. Let's go to page 23. Page 23. Let's go to page 23. Question number 1 of page 23. Question number 1 of page 23. As shown in the diagram, a mercury column is trapped inside a glass tube with one end closed. If the atmospheric pressure P0, what is the statement which shows the pressure P of air inside the closed glass tube? Density of mercury is rho. Okay, so this is the idea. Okay, this is the idea. So there's a system like this. Here the pressure is P0. Here the pressure is P. This height is H2. This height is H2. This height is H1. What is P? So this is the idea, okay? This is the idea. I'm going to use two theorems related with hydrostatics here. What are they? Pressure at the same level of a liquid is equal. So pressure here is equal to the pressure here, right? Pressure here is equal to the pressure here. Pressure at the same level of a liquid is equal, clear? Pressure at the same level of a liquid is equal. So the pressure here, if it is P1, pressure here, it is also P1 here. This P1, I can write, the pressure here is P, pressure here is P plus H2 rho G, right? P plus H2 rho G. It can be written as P plus this height H2 rho G. Then pressure here can be written from this side. How? Pressure here is P naught. Then this height is H1. So it is P naught plus H1 rho G. It is P naught plus H1 rho G here. So then this P1 and this P1 is equal. It's the same pressure. Why? The pressure at the same level is equal. Clear? Pressure at the same level is equal. So this one is equal to this one. So P plus H2 rho G, P plus H2 rho G equals here P naught plus H1 rho G. P plus H2 rho G equals P naught plus H1 rho G. Okay, so I can get what? I can get P equals P naught plus H1 rho G minus H2 rho G. Okay, P equals P naught plus H1 rho G minus H2 rho G. Here, minus H2 rho G. Here, that is the pressure here. Got the idea? That is the pressure here. Here, you can solve it and get the pressure like that. Here, you can solve it and get the pressure like that. And if the PDFs shown in the screen is not clear enough, you can always get the tute from the group. You can always get the tute from the group. and from the WhatsApp channel, and refer to that. Okay. So the channel link will be available in the Zoom chat and in the YouTube live chat now. Okay. So both group link and WhatsApp channel link will be available in the Zoom chat and in the YouTube live chat. Okay. And in the YouTube live chat, you can join the channel from that, get the PDF from there, then refer to that. Okay. Okay. Let's move forward. Let's move forward. Okay. Let's go to question 7 of page 25. Question 7 of page 25. Let's do question 7 of page 25. Let's go to question 7 of page 25. Question 7 of page 25. What is the weight? What is the weight of the water displaced by the wooden block which has the mass of 5 kilogram in air? What is the weight of the water displaced by this wooden block which has a mass of 5 kilogram in air? So this is the idea. This is the idea. The mass of the object is 5 kilograms. Mass of the object is 5 kilograms. That means its actual weight is 50 newtons. Clear? Its actual weight is 50 newtons. Clear? It has an actual weight of 50 newtons. So if you hang this by a spring balance, if you hang this by a spring balance, the spring balance should show 50 newtons. Okay. Spring balance should show 50 newtons. But now, when you put it in water, it shows just 40 newtons. It shows just 40 newtons. So there's a difference of 10 newtons, right? There's a difference of 10 newtons. So what is this difference? Let me know. Mention in the Zoom chat. What is this difference? What is this difference? What is this difference? Yes, it is the upthrust. Nice. Nice. It is the upthrust. This difference is upthrust. This 10 Newton difference is created by the upward upthrust on the object. Upward upthrust on the object. Okay. This difference of 10 newtons is created by the upward upthrust on the object. Here, by the upward upthrust, 10 newtons of the object. Okay. Now, what is Archimedes law? What does Archimedes mentions? The upthrust is equal to the weight of the displaced volume of liquid. Can you remember? Upthrust is equal to the weight of the displaced volume of liquid. So they are asking the weight of the displaced volume of liquid. In this question, what they are asking is, they are asking for the weight of the displaced volume of liquid. That means they are actually asking for the upthrust, right? They are actually asking for the upthrust, which is 10 newtons, right? They are actually asking for the upthrust, which is directly 10 newtons. Here, so that is the idea. That is the idea. So the answer is 10 newtons. Here, answer is 10 newtons. Let's go to question number 6. Let's go to question number 6 of page number 25. Question number 6 of page number 25. Let's go to question number 6 of page number 25. Pressure exerted on the submarine, which is at the depth of 3000 meters in the sea, density of seawater 1050, gravitational acceleration 10, atmospheric pressure 103,360 pascals. Okay. Question 6 on page number 25. So what is the meaning of that? There's a submarine. This is the water surface. There's a submarine here. Okay. It's at a depth of 3000 meters. It's at a depth of 3000 meters. Here. It's at a depth of 3000 meters. So now, there's this atmospheric pressure feeling here. The atmospheric pressure feeling here is 103,360. 103,360 pascals. Okay. Atmospheric pressure feeling here is 103,360 pascals. Then what is the pressure at this level? It should be P naught plus H rho G, right? It should be P naught plus H rho G. Why? You have P naught here, you have P naught here, and you have H rho G here. Clear? P naught here and H rho G here. So it's P naught plus the H rho G. So what is the value? P naught is this 103,360 plus H rho G. Height is 3000 meters. Height is 3000 meters. Rho means density. Density is given as 1050. Density is given as 1050. G means 10. G means 10. Clear? G means 10. So it is H rho G. H rho G. So what do we get when we calculate this? What do we get when we calculate this? It is 103,360 plus 3000 into 10 Yeah, you have to use the logbook for this. Okay, if you're unable to do the calculation directly to save some, I'm using the calculator. It's 103,360 plus 3000 into 1050 into 10. Okay, so this gives you 316 0 336 0 Pascal. Here, this is the answer here. So I'm actually like skipping some questions because some questions may be a bit unnecessary at this level, because I mean we produced this book long before. Those days students had a lot of time, like 3-4 months for the exams. We started giving it away like 3 months before. So then you had time to analyze different questions, go through like both essential questions and both nice but difficult questions. You had all those possibilities then. But now it is very close to O level, so we don't have to go through like extremely difficult or unnecessary questions. So I'm focusing a lot on the questions that would support you in getting some marks in the exam. Okay, I'm actually focusing on the questions that would support you in getting some marks in the examination. Okay, instead of going through the most difficult questions. Okay, but I'm not going to go to the simplest questions too. Okay, so that is the plan. But anyways, a print typed answer script will be provided for the tute. Okay, that is the idea. Okay, so let me know until now, is it okay? Do you learning something, or you need me to do more difficult questions, or you need me to do more easy questions? What's your idea? Until students mention that, until students mention that, like there was the question, why do we add the atmospheric pressure? Why? This surface is anyways feeling the atmospheric pressure. Okay, this surface is anyways feeling the atmospheric pressure. So it is the atmospheric pressure here plus H rho g here. It is the atmospheric pressure here plus the H rho g here. That is the pressure here. Not just that, not just the H rho g value. The atmospheric pressure is felt here, and you have to add this H rho g to that. Here, you get the atmospheric pressure, and add the additional pressure by water, then you get the total pressure. Okay, then you get the total pressure. Understood? The students who asked the question, understood? Okay, let's move to page 24. Page 24, question 2. Page 24, question 2. Let's move to page 24, question 2. What is the difference of pressure created between point X at the bottom of the tank and point Y when water removed through this siphon tube? Density of the liquid rho, gravitational acceleration g, and the atmospheric pressure P naught. What is the pressure difference between X and Y? What is the Pressure difference between X and Y. So, page 24, question 2. So, this is actually a siphon system, and luckily they are at the same height here. So, the real method, real physics behind siphon system, you will only learn in A-level physics, okay? If you like, you can search. There's something called Bernoulli's theorem. There's something called Bernoulli's theorem. Bernoulli's theorem is what dictates this, okay? Bernoulli's theorem is the theorem that dictates this, okay? Not the actual way you learn in all levels, okay? But things, I mean, this is not a good time to teach stuff beyond O levels a lot because we are very close to O levels. Let's stay in the limits of O levels. And anyhow, if you are doing maths or bio for A levels, we'll do that, okay? So now, this position and this position they are talking about. So everywhere you have the atmosphere, okay? Everywhere you have the atmosphere, okay? So this is atmosphere, so the pressure here is P naught. This is atmosphere, so the pressure here is P naught. Why? It is in contact with atmosphere, okay? It is in contact with atmosphere. This point is in contact with atmosphere, so it is P naught. And this is also in contact with atmosphere, so it is also P naught, okay? This is also in contact with atmosphere, so it is also P naught. And this height is H. This height is H. So what is the pressure here then? What is the pressure here? Pressure here is actually the pressure here. I mean, it's the same place, right? Same level. So the pressure here is, here you have the atmospheric pressure P naught. Here you have the atmospheric pressure P naught and an additional of H rho G. And an additional of H rho G. So it is P naught plus H rho G. Clear? It is P naught plus H rho G. That is the pressure here, Px. Px. Then the pressure here, Py, it is directly in contact with atmosphere. See, it is directly in contact with atmosphere. It is connected with the atmosphere, so it is anyways P naught. Here, it is in contact with atmosphere, so it is P naught. So the difference between x and y is actually Px minus Py. It is actually Px minus Py. What is Px? It is P naught plus H rho G. Px is P naught plus H rho G. Minus, what is Py? Py is P naught. Py is P naught. Then P naught cancels out, you get H rho G. Here, P naught cancels out, you get H rho G. Here, so P naught plus H rho G minus P naught, you get H rho G. Here, you get H rho G. So the pressure difference between here and here is H rho G. Pressure difference between 2 points is H rho G. Okay. Then next, we had energy. We did a separate session about energy, so you can watch that if you need theory. There are two types of energy, half mv squared kinetic energy. There are actually two types of energy in our syllabus. Okay, there's more energy types than this, but there's main two types of energy. One is kinetic energy and other one is potential energy. And there's work done, it is Fx. That means you apply a force on an object, and under this force, if it moves the distance of x, work done becomes Fx. Work done becomes Fx. Okay. Go to page. And again, power could be written as energy over time. Power could be written as energy over time. How fast the energy is consumed. Okay. Power means how fast the energy is consumed. Okay, so power is energy over time. Let's go to page 29, question 1. Let's go to page 29, question 1. The time taken to lift an object of mass 10 kilogram to the highest position is 42 minutes. The rate of doing work is. So, this question. Try that until I erase the board. Okay, so it's not necessary to analyze the steps. Okay, yes, I know this is question 1 of page 29. So it's actually a system like this, then this, then this, then this. It's like this. This distance is 40, and this height is 24. This height is 24. Then this is 10 kilograms. This is 10 kilograms. Then you take it here. Okay. So if you try to analyze it step by step, it's a lot of work. But what is nice here is what is actually happening is it's going from a lower level to a higher level, right? It is actually going from a lower level to a higher level. What is the energy that involves with the height? Tell me in the Zoom chat. What is the energy? And in the YouTube live chat, what is the energy that is involved with the height? What is the energy that is involved with the height? What is the energy that is involved with the height? It's potential energy. So the actual energy difference here is the potential energy of the object. Okay. Actual energy difference here is the potential energy of the object, and potential energy involves only the height. Potential energy involves only the height of the object. Clear? Potential energy involves only the height of the object. So the mass is 10 kilograms. G means 10. And height is 24. M G H. Okay. M G H. Mass is 10 kilograms. G is 10. Height is just 24. What matters is just the height. Okay. So then we get 24, 2 zeros of joules. But what they're asking is rate of doing work. What is rate of doing work? That means power or energy over time. Power, that means energy over time. They're asking for the energy over time. They're asking for the power. Okay. So that means 2400 joules. 2400 joules divided by time, which is 42 minutes. Time is 42 minutes. I will convert that into seconds. That's the answer sign, joules per second. So I can't write it in minutes. I have to convert it into seconds. To convert minutes into seconds, you multiply things by 60. So how can you solve this? It's 2400 into 42 into 60. This 60 and this gives you 40 and 1 gives you 40 and 1. Then you have what? 40 over 42. Then you have, I think my calculations are correct, 0 and 0 cancels out. Yes, it's 40 over 42. I think there's a small issue with the answers there, right? None of the answers are below 1. This is an answer below 1, right? Let's check the question again. The time taken to lift the object of mass 10 kilograms to the highest position is 42 minutes. Rate of doing work is, so the energy difference is mgh. Energy difference is mgh. M is 10 kilograms, G is 10, and it is going to a height of 24 meters. So then we get 2400 joules divided by time 42 minutes. 42 minutes. Yes, when I solve this, I get, I'm not getting an answer even in the answers, right? It's 2400 over 42 into 60. It's 0.95. But anyways, we can go for the closest answer, right? We can go for the closest answer. This gives us 0.95. This gives us, when you solve this, you get 0.95 something. So 0.95 means almost 1. 0.95 means almost 1. So we can go with this answer, 1 joules per second. We can go with 1 joules per second. Clear? 0.95 is almost 1. Clear? So the answer is 1 joules per second. Okay. And about current electricity, okay. About current electricity, I did a whole series of questions. So I did an entirely separate session, okay. About current electricity, I did an entirely separate session. So I don't think I have to go through the theory of current electricity again, okay. I don't think that I have to go through the theory of current electricity again, and so I can jump directly into questions about current electricity, okay. And if you like, okay, this is something additional. Most of you may have learned this too. Instead of applying motion equations, you can use energy. Okay, this is something extra. Instead of applying drawing motion graphs, for some motion questions, you can use energy. How? Assume a mass of 5 kilograms is dropped from zero velocity, and it falls for 200 meters or 20 meters. It falls for 20 meters. When it falls for 20 meters, what is its velocity? Things like this, a very simple question like this. If you want, you can use energy in these kind of scenarios, okay? You can use energy for these kind of scenarios. How? How can you use energy here? There's a universal rule, okay? There's a universal rule, that is energy can never be invented or destroyed, okay? Energy can never be invented or destroyed. That means it is just there, okay? It is just there. That means energy can only be converted, okay? Energy can only be converted. So when I release something like this, its velocity increases. Why? Because its potential energy decreases. Clear? Because its potential energy decreases. This decreasing potential energy converts into kinetic energy in this scenario. Clear? This decreasing potential energy, the decrease of potential energy, when it goes down, converts into kinetic energy. Clear? It converts into kinetic energy. So what I can actually write is the potential energy lost, mgh, potential energy lost from here to here, which is mgh. Potential energy lost from here to here, mgh, is equal to half mv squared. That means the kinetic energy gained. What is actually happening is potential energy we lose and it turns into kinetic energy. It turns into kinetic energy. So m is 5 kilograms, g is 10, h is 20, equals half. Again, m is 5 kilograms. Here I have v squared. Here I have v squared. So this 5 and this 5 cancels out. Here I have v squared. I bring this 2 here. Then I get 2 into 10 into 20. I bring this 2 here. So I get 2 into 10 into 20. Then I get 20 into 20, which means 20 squared. Then I get 20 into 20, which means 20 squared. So v squared equals 20 squared. So v equals 20. V squared equals 20 squared. So v is 20 meters per second. Here v squared is 20 squared. So v is 20 meters per second in this scenario. See? So it's gaining a velocity of 20 meters per second. Okay. Like that, there are some options like this too. Okay. Instead of drawing motion graphs, instead of using equations like s equals 5t squared, instead of all of them, even you can use energy relationships. Okay. Energy relationships. There are options like that. Clear? Got the idea? Did you understand that? Everyone? Did you understand that, people? Okay. So since it is a lot of time, I'll give you a small break. Okay. I'll give you a small break. The time is, and just let me know whether the session is useful and all. Okay. You understand things that I mentioned? And is it useful actually? So I'll give you a small break. It's 4. It's actually 4. I'll start in 10 minutes. Okay. I'll start in 10 minutes. Okay. I'll start at 10 past 4. Okay. I mean, I just need you to go outside. Okay. Walk out from your room, jump a bit, run a bit, drink some water. Okay. Don't take your mobile phone and start scrolling. Okay. Okay. Don't take your mobile phone and start scrolling. I just need to keep you off the screen for 10 minutes. That's why. Otherwise, it will be difficult to focus. So I'll give you 10 minutes. Okay. Roughly 10 minutes. Okay. Like, just walk outside and return. Okay. Okay, let's start. Some students have mentioned like the electronic questions are a bit hard and all. Yes, I mean, I'll do some sessions for that too. I'll try to arrange some electronic questions like that. Just mention what are the areas you find hard, okay? Mention what are the areas you find hard, so I can create and like find some questions in that area and do a discussion, okay? Yeah. So just let us know. Let us know what are the areas you need us to discuss. Okay, let's move forward. Let's move forward. So electricity, I'm not going to discuss theory, okay? Electricity, I'm not going to discuss theory because I did a whole session about that. Those questions, like you can find them in our channel, in our WhatsApp channel, and in the WhatsApp group also, and we'll provide all the information today in the group. Okay. So about the current electricity part, okay? About the current electricity part, let's go to page 35. Page 35. Question number 2. Page 35. Question number 2. What is the correct answer for the equivalent resistance of P and Q in the above circuit? What is the correct answer for the equivalent resistance of P and Q in the above circuit? So here you have P, here you have P, here then you have 2 ohms, then 6, 6, 6, 6 ohms, 6 ohms and 6 ohms. Again 2 ohms, then another 6 ohms. Another 6 ohms. So this is the setup. This is the setup. What is the correct answer for the equivalent resistance of P and Q of the above circuit? Okay. So first thing is understanding what are series and what are parallel. So first of all, see these three. See these three. These three are parallel, right? These three are parallel. So what is the equation for the resultant of parallel resistors? 1 over R equals 1 over 6 plus 1 over 6 plus 1 over 6, which gives me 3 over 6. So R is 6 over 3. R is 6 over 3. So the actual idea is, if you have few equal resistors in parallel, if you have a few equal resistors in parallel, n number of equal resistors in parallel, equivalent is equal to R over N, okay? R over N. So here also it's 3 parallel resistors of 6. So the equivalent or the resultant is 6 over 3. If it was small R resistors, then it is R over N for N number of resistors. So you get 2 ohms. You get 2 ohms here, okay? Answer is 2 ohms. So now, here you have 2 ohms, okay? Here you have 2 ohms. This part. Then again simplify the system. Now this is 2. This is 2. Here this whole part is a 2. This whole part is a 2 and this is again 2. 2, 2 and 2. Then you have a 6 here. Then you have a 6 here. This is P and this is Q. These three are series. Can you see? These three are series. Can you see? These three are series. 2, 2 and 2. Then the overall is 6. Overall is 6. Okay. These three are series. So the overall is 6. P. This is 6. Okay. Overall is 6. Clear? Then it's a 6 here. 2 plus 2 plus 2, it's a 6 here. Then another 6 here, down here. Here. Then it's another 6 down here. Here. It's a 6 here. 2 plus 2 plus 2, 6 here. Another 6 down here. And these two are again parallel, right? See? These two are again parallel. So again, 1 over R equals 1 over 6 plus 1 over 6. It is actually 2 resistors of 6. So the resultant is 6 over 2. Shift. Resultant is 6 over 2, which gives me 3 ohms. Okay. Which gives me 3 ohms. That's how you get the resultant there. Okay. That's how you get the resultant there. Let's go to question 5 of page number 36. Question 5 of page number 36. Question 5 of page number 36. Topmost question of page number 36. The given activity prepared to test the Ohm's law in the lab. Identify x and y and state the function of x. Draw a graph to show the relationship between v and I. Write down the equation that you gain from the above activity. Write down the quantities that can be measured by A and V. There are 4 questions, okay? There are 4 questions, okay? They first need us to know what is x and y, then draw a graph between V and I. Write down the equation that you gain from the above activity. Write down the quantities that can be measured by A and V. So the system is like this. System is like this. There's a battery here. There's a battery here. Then you can find x, y here. Then you can find y here. Then there's an ammeter here. There's an ammeter here. Then there's a variable resistor here. Then this is V, voltmeter. This is V, voltmeter. Okay. Okay. So actually, ideally, the voltmeter should have been connected to Y. Then it would be much convenient. Okay. Then it should be much convenient. I think it is a small issue in the question, but still this question is manageable. Okay. Still this question is manageable. Still this question is manageable, not in the range of all levels. If we connect the voltmeter to the battery, you will find it bit difficult to analyze. Okay. You will find it bit difficult to analyze if we connect the voltmeter to the battery. Okay. Because you have such equations in A levels. V equals E minus IR. In your syllabus, all you have is V equals IR. So let's change the location of the voltmeter. Now answer this. It would be much easier now. Okay. It would be much easier now. So the first question, x and y. What is x and what is y? So it's like this. Y is a constant resistor or some kind of a load. This is the constant resistor that I decide that I use for analysis. This is the constant resistor that I use for analysis. That means this is actually Ohm's law, proving Ohm's law. So to prove Ohm's law, what we do is we get a constant resistor. We get a constant resistor. We analyze the voltage and the current through that, right? We get a constant resistor and we analyze the voltage and the current through that. Here, voltage and the current through that. That's what we do. Okay? In a constant resistor. So now, in this case, this is that constant resistor that we use to analyze. This X is a variable resistor. It's a variable resistor. Why do we use a variable resistor? We need to change the current in the path. Because I need to create the relationship between V and I. If I change the current in the path, I changes. I can't change the battery. I can't just keep changing the battery. It's a lot of work. So the solution here is, okay. So the solution here is, the solution we have here is, we use a variable resistor. So that I can change the current in the path. So this is a constant resistor that I use for analysis. This is a variable resistor. Draw a graph to show the relationship between V and I. Okay. So we know through a constant resistor, graph between V and I would be a linear graph like this, right? It will be a linear graph like this. Write down the equation that you gain from this activity. What is the equation we create from this activity? Equation is V proportional to I. This is Ohm's law. Then the proportionality constant becomes R. Then we get V equals Ri. Here, we get V equals Ri. Okay. Or else V equals IR. Okay. This is the equation that we get through this activity. Write down the quantities that can be measured by A and V. What can be measured by A? A is an ammeter. Ammeters measure current through that. V is a voltmeter. Voltmeters measure the voltage of a device. Voltmeter measures the voltage of a device. Ammeter measures the current through a device. Here, ammeter measures the current through a device. Voltmeter measures the voltage through a device. Okay, I'll connect two things and ask a question. Let's go to question 6. Of page 36. Question 6 of page 36. Let's go to question 6 of page 36. When the bulb is connected to a 12-volt power supply, a current of 0.0 ampere flows. What is the resistance of the filament of the bulb? I need to do some addition to this question. I need you to find the resistance and the power of this bulb. Because can you remember there's a separate area in your syllabus about power of electrical devices, power and energy of electrical devices. That part also I did a session, okay, in the same session as current electricity. I think I discussed that. So go to 6. Write down the answers. Write down the answers. So there's a bulb. There's a bulb. We provide 12 volts to that. We provide 12 volts to that. Then a current of 0.5 ampere flows through that. Then a current of 0.5 ampere flows through that. What is the resistance of the filament of the bulb of that instance? So we use V equals IR. Here we use V equals IR. So the voltage is 12 volts. Voltage is 12 volts. Current is 0.5 amperes. Current is 0.5 amperes. Then the resistance is R. 12 volts equals current 0.5 amperes. Resistance is R. So 12 equals 0.5 means half into R. So R becomes, you take this 2 here. So 12 into 2 gives us 24 ohms. Gives us 24 ohms. Then the power of an electrical appliance, can you remember, can be taken as P equals VI. Power could be taken using P equals VI. So what is V? It is 12 volts. What is V? It is 12 volts. What is the current? It is 0.5 amperes. Current is 0.5 amperes. P equals VI. Then you can get 12 into current is half. You get 6 watts. You get 6 watts. Okay. You get 6 watts here. And there's another thing. Okay. And there's another thing here. I mean, something additional that I need you to know. Sometimes for resistors, you can combine these two equations. This is something additional, but it's good to know this. Sometimes for resistors, you can add these two. You can add these two equations. That means there's one equation that is P equals VI. One equation is P equals VI, and other equation is V equals IR. V equals IR. Sometimes you may need, or you can combine these two equations. How? You have P here, you have I here. Instead of V, I write IR. See, instead of V, I can write IR. I can replace V by IR. See, I can replace V by IR. See, so instead of V, I can write IR. Then we get I squared R. Then we get what? We get I squared R. V equals I squared R. Okay. So sometimes this equation makes our life easy. Why? Just assume that there's a resistance of 5 ohms, a current of 2 amperes. There's a resistance of 5 ohms and a current of 2 amperes. Then what is the power? You don't have to apply P equals VI or anything. Okay, you don't have to apply P equals VI or anything. What you could do is, you have I squared R equation now. So instead of I, you write the current 2 ampere. So it becomes 2 squared. It becomes 2 squared. And the resistance is 5 ohms. See, sometimes you can combine these equations. Here, current is 2 amperes. So you get 2 squared. And the resistance is 5 ohms. So you get 2 squared. That means 4 into 5. 2 squared, that means 4 into 5, which gives you 20 watts. Which gives you 20 watts. This is power of electrical appliances. P equals VI. This is Ohm's law. V equals IR. You combine these two equations. You replace V by IR. Then you get IRI. That means I squared R. See? Did you understand that? Mention in the chat. Did you understand that? Okay, let's move forward. Let's move forward. Let's go to question 8. Question 8 of page 37. Let's go to question 8 of page 37. Question 8 of page 37. Three equal resistors whose resistances are two cells with equal electromotive forces and two equal bulbs were connected to P and Q. Bulb in which the circuit has the highest brightness after choosing the switch. Mention the reason for reducing the brightness of the bulb in one circuit. Name the types of combinations of the resistors P and Q respectively. Write suitable equations for find the equivalent resistance R, P and Q separately. If the equivalent resistance and the electromotive force is 2 ohms and 6 volts respectively, find the current flow through the circuit. Copy one of the circuit given above and show in a diagram how to connect a voltmeter to measure the electromotive force. Okay, so this is the idea. This is the idea. I'll quickly go through this question. Okay, so there are two networks like this. Okay, there are two networks like this. One network like this. One network like this. Everything is same other than this. And a bulb like this. And there's another one network like this and a series system like this. Series system like this. So the first question, bulb in which the circuit has the highest brightness. So the idea is we have the highest brightness in this one, okay? Why? If I simplify the network, if all resistors are okay, if the resistors are R here, the total resistance here would be R over 3. Total resistance here would be R over 3 and the electromotive force is E. Then here electromotive force is E. Total resistance here is 3R. 3R. Why? 3 resistors in series, it becomes 3R. 3 resistors in parallel, it becomes R over 3. Okay. What is the equation for this? It is 1 over R. 1 equals 1 over R, 1 over R and 1 over R for parallel resistors, which gives me 1 over R1 equals 3 over R. So R1 equals R over 3. Then here it is just R2 equals RRR. RRR in series gives me 3R. Clear? R and R in series gives me 3R. So this is R over 3. This is 3R. So definitely V equals IR. Higher the resistance, lower the current, right? See, higher the resistance, lower the current. Why? Current equals V over R. See, current equals V over R. So higher the resistance, lower the current. So we have a higher resistance here. We have a higher resistance here than this. Resistance is higher in this one than this. So we have a lower current here, higher current here. If we have a higher current here, this bulb will have a higher brightness, right? Then this bulb will have a higher brightness. More current means more brightness. Clear? More current means more brightness. Clear? That's the idea. Okay. So here the resistance is lower. So the current is higher. If the resistance is lower, current is higher. If the current is higher, brightness is higher. Reason for reducing the brightness of bulb in one circuit. So this brightness is lower. What is the reason? Because the circuit has a higher resistance. That is the answer for the second one. Answer for the second one is, in the second circuit, it has a higher resistance. In the second circuit, it has a higher resistance which reduces the current. It has a higher resistance which reduces the current. So the brightness is lower. So the brightness is lower. Name the types of combination of resistors P and Q respectively. In P, this is parallel configuration. We call this parallel configuration. In the second one, we call this a series configuration. Clear? In the second one, we call that a series configuration. This is a parallel configuration and this is a series configuration. Parallel and series. So third one is also easy. Fourth one, write a suitable equation to find the equivalent resistance R of P and Q respectively. You know that, right? I already wrote them. See, this is the equation. 1 over R1 equals 1 over R, 1 over R, 1 over R. This is the resultant of the first network. In the second network, the resultant is R2. Resultant is R2 equals R plus R plus R. R plus R plus R. Here, R2 is R plus R plus R. These are the suitable equations to get the resultant. Okay. Next, if the equivalent resistance and the electromotive force is 2 ohms and 6 volts respectively, find the current flow through the circuit. So they have given us the equivalent resistance. In a network, they have given us the equivalent resistance. That means the total resistance is given. And they have given me the electromotive force or else the voltage produced by the battery. Electromotive force means the voltage produced by the battery. It is 6 volts. Battery produces a voltage of 6 volt and the equivalent resistance is 2 ohms. Battery produces a voltage of 6 volts and the resistance is 2 ohms. Find the current through the circuit. Find the current flow through the circuit. So V equals IR. V equals IR. Okay. Circuit feels a total voltage of 6 volts. Circuit feels a total voltage of 6 volts and the current is I. Resistance is 2 ohms. Resistance is 2 ohms. Circuit feels a total voltage of 6 volts. I need to find the current of the circuit and the total resistance is 2 ohms. When I solve this, I get current equals 6 over 2, which gives me 3 ampere. Which gives me 3 ampere. Copy one of the circuits given above and show in a diagram how to connect a voltmeter to measure the electromotive force. So the idea is in any system like this, whether it's parallel or whether it's series, if you need to measure the electromotive force of the battery, that means it is the voltage produced by the battery. To measure that, you should measure the voltage of the battery. So for that, you should connect the voltmeter to the battery. For that, you should connect the voltmeter to the battery, not to anything else. Voltmeter should be connected to the battery. Yeah. Then only you can find the electromotive force. Okay. Then only you can find the electromotive force of the battery. Here. That's how we find the electromotive force of a battery. Okay, let's go do some waves questions and stop the session for today. And I'll arrange another session for next series of questions. Okay, I'll arrange another session for next set of questions. Let's do some waves questions and stop the session for today. Let's go to page. Let's go to page 42. Go to page 42. Question number 1 of page 42. Question number 1 of page 42. An ultrasound wave emitted by the instrument reflected back after the part of the destroyed ship and noted in 500. Find the depth from the ship to the part of the destroyed ship. Part of the destroyed ship. So the idea is this. So this is ultrasound technology. Okay. Have you seen the bird view of vehicles? Recent vehicles have a bird view. You see the vehicle, how it sees from above. You see the vehicle as how you see it from above. That also use a technology like this. What we do is we just send thousands of signals around. Okay, if you do engineering, you will learn how to develop these kind of technologies, how to work with these kind of technologies. It just emits thousands of waves around, and based on how fast they return, based on how fast these waves returns back to the vehicle, they analyze the shape of the surrounding, whether there's a tree here, whether there's a rock here. They analyze the shape of the surrounding. We call that LiDAR technology. LiDAR technology. Okay. If you ever get into engineering, you will learn this kind of stuff and how to develop these technologies. It's quite fascinating. Okay. It's quite fascinating how these things work. This is the simplest form of that. Okay. Sonar technology. Sonar technology. This is the simplest form of that. How we emit a sound wave and it collides at something and returns. It collides at something and returns. Using that, we measure the distance. So if the distance between the ultrasound and the broken ship is h, this sound wave should travel the distance of 2h. Why? It should go h down and it should go h up. So the total distance is 2h. Here, total distance it travels is 2h. Here, and distance over time is velocity. Distance over time is velocity. Here, velocity is distance over time. So here the distance is 2h, h up, h down. So the distance is 2h, h up and h down. Here the distance is 2h. Here divided by time. What is the time given by them? It took 0.4 seconds. It took 0.4 seconds to reach to the ultrasound machine again. It took 0.4 seconds to return. Okay. equals, what is the velocity of sound in seawater? It is given as 1500. Okay, it is given as 1500. So you solve this. H equals 1500 into zero point 0.4 into zero point 0.4 divided by 2. So what would you get here? 1500 0.4 divided by 2 gives me 0.2. Then I get 150 into 2. I multiply this by 10, divide this by 10, divide this by 10, then get 150, multiply this by 2, then I get 2. Then gives me 300 meters. This gives me what? 300 meters. They haven't asked us to do the calculation, right? Okay. They have directly given us the equation. Then the answer is 4. Answer is 4. 1500 into 0.4 divided by 2. Okay. 1500 into 0.4 divided by 2. Let's go to question 3 and 4. Both. Let's read them both at the same time and finish them at the same time. Of question 42. Sorry, page 42. Page 42, go to question 3 and 4. Page 42, go to 3 and 4. One is, which characteristic of sound helps to identify the instrument when playing a song noted by two instruments? Then question 4, what properties of electrical signal received from the microphone is amplified by the amplifier? Okay. Okay, there are two questions. Question 3 and question 4. Which characteristic helps us to identify an instrument? Sometimes both the frequencies of the signals are equal, both the amplitudes of the signals are equal. Sometimes both the frequencies and amplitudes of the signals are equal. But different instruments produce different wave shapes. Okay. Okay. So like there's a small issue with the YouTube live. But anyways, we are towards the end of the session, so no worries. What happens in a amplifier? It actually amplifies the electrical signal, okay? That's why I produce a very weak signal by my mouth, but we need to hear it louder. Loudness depends on the amplitude. Clear? Loudness depends on the amplitude. So what we should do is the electrical signals amplitude should be increased. Clear? Electrical signals amplitude should be increased to hear it properly. Clear? To hear it properly. Okay? So that is the idea. Okay? Electrical signals amplitude should be increased. So what property of electrical signal? It is the amplitude of the electrical signal that is improved through an amplifier. So that's all for today. I'll arrange another session for you guys. Okay? I'll arrange another session for you guys. We can finish other stuff through that. Okay? I'll let you know and just let us know whether the session was useful or not. And if you have any questions, contact this number, not 70154 6825. It's not 7015466825. And we'll let you know about the next sessions too. Okay. So let's meet again, and thank you for joining. And I think there have been a small issue on the YouTube live. We'll provide the recording of that part in the group. Okay. So no worries about that. Okay. Recording will be provided in the group. Okay. So thank you for joining with the session. Okay. Thank you for joining with the session. So I think the live students didn't miss much. Okay. I think the live students didn't miss much. So no worries about that. And let's meet with the next session. Okay. Let's meet with the next session, and I'll let you know about the details in the group. So everyone join our WhatsApp channel and the WhatsApp group. Okay. Thank you for joining.